Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera to everyone. So we are moving to the second part of this topic under soil classification. Okay, previously we already discussed on particle size analysis test, which is include of civic analysis and also sedimentation analysis. So remember, there's two sets of testing. Okay, one is particle size analysis, another one is Atterberg limit test. Okay, for laboratory testing, okay, to be carried out in order for you to classify the soil. Okay, before you can classify the soil, there's a two sets of testing that you need to carry out. So it means that you need those two sets of data. Okay, so you have particle size and also Atterberg limit test. And remember, when you're talking about particle size analysis, which means that the assessment, okay, the assessment is based on what? Based on the texture, okay, which means you're looking at the size and also the shape of the particles. Okay, so you can quantify, okay, quantify the percentage of, okay, you are able to quantify the percentage of coarse and also the percentage of fine. Okay, but if you're talking about sieve analysis, okay, definitely you can get these two. You get percentage of coarse and also percentage of fine. But in addition to that, okay, you can also identify the percentage of gravel and also the percentage of sand, okay, which is belongs to coarse grain soil. But you have no idea, okay, what are the percentage, okay, of clay and also what are the percentage of silts. You cannot get this one from sieve analysis. Okay, you cannot further identify what are the types of fine grain soil. So if, let's say, okay, from the sieve analysis results, you know what are the percentage of fine grain soil, okay, which has, for example, that it has a sufficient amounts of fine grain soil. Let's say it has more than 12%. So we're talking about this number. Okay, let's say it has more than 10 or 12% of fine grain soil, which considered as significant, okay, to influence the behavior of soil. Then you want to know that 12% is belongs to what? Which one is domain? Either it is clay or silt. So what you need to do is to carry out this Atterberg limit test. Okay, so from Atterberg limit test, okay, the determinations is actually based on moisture content. Okay, but you are looking for what? You are looking for types of fine grain soil. So you are looking at the types of fine grain soil. It's either clay or silt. Which one is dominant? So there's nothing to do with coarse. You are not talking about coarse anymore. In Atterberg limit test, you are not talking about coarse grain soil. No, you just want to know what are the types of fine grain soil. All right. So therefore, okay, from the sieve analysis test, okay, whatever particle that passing sieve number 200, okay, whatever particle that passing sieve number 200, that would be your sample. Okay, sample for Atterberg limit test. So for Atterberg limit test, you have two tests, which is liquid limit and also plastic limit. Okay, you need to carry out those two testing, okay, in order for you to further identify the types of fine grain soil. Either it's dominated by clay or silt. So what is actually Atterberg limit test? Okay, this test is carried out to further classify type of cohesive soil. Okay, remember when I say that cohesive, okay, cohesive soil, it means that we are talking about fine grain soil. Okay, and the definition is associated to moisture content, which deform, okay, which deform from plastic to liquid. Okay, so if you look at this figure, okay, look at this figure. Okay, we know that this is your moisture content, so it means that more water, it means that you have more higher moisture content. So the stage of soil would change from brittle to solid and finally to liquid. Okay, from brittle to plastic and finally to will transform to liquid stage of soil with increasing moisture content. Okay, so based on the data, the soil may classify to certain classes of brittle solid, plastic solid, and also liquid stage. Okay, so what is actually the plastic limit? Okay, plastic limit is the limit between plastic and brittle failure. So this is your plastic limit. Okay, is the limit between plastic and also brittle solid. So there is a boundary that change the soil from brittle to solid. So this is the minimum, okay, what I can say, the minimum amounts of water content, okay, water content or moisture content. Okay, the plastic limit and liquid limit both, when talking about plastic limit and also liquid limit is both, we are talking about determinations of moisture content. So the plastic limit is the minimum amounts of soil to behave as plastic. Okay, that is the minimum amounts of soil, okay, to behave as plastic. And when talking about liquid limit, it means that you're talking about the moisture content. Okay, talking about liquid limit, it means that you're talking about the moisture content in the soil when it stops acting as liquid. Okay, it stops acting as liquid and start acting as plastic solid. Okay, that means by liquid limit. Okay, which means that the liquid limit is the minimum amounts of soil. Okay, not minimum amount, sorry, the minimum amounts of water. Okay, for that particular soil to behave as liquid. Okay, to behave as liquid. But what actually plastic limit and liquid limit? It is both are the moisture content. Okay, but the moisture content when the soil behave as what stage of soil? Either it's behave as plastic or it behave as a liquid. And it is a boundary between the transitions. Okay, for example, the plastic limit is the transition between from brittle to plastic, and liquid limit is the transition from plastic to liquid. And what is actually you're looking for from plastic limit and liquid limit? From plastic and liquid limit, okay, you are looking for actually is the plasticity index. Okay, the PI value. Be careful, PI is not similar to PL. Okay, PL, we're talking about PL is plastic limit. PI is plasticity index. So plasticity index here is liquid limit minus plastic limit. Okay, PI is liquid limit plus minus plastic limit. So when you have a similar type of soil, okay, being tested, okay, one is tested for liquid limit, one is at the plastic limit, definitely the liquid limit water content must be higher than plastic limit water content, okay, for a given similar type of soil. Okay, because we know that when talking about liquid, it is start to behave as a liquid. Okay, after carrying out both liquid limit and plastic limit, the results then will be further analyzed to enable cohesive soils to be classified physically and the probably type of fine-grained soil to be assessed. So classification is usually accomplished by means of plasticity chart as shown here. So this is the plasticity chart. Okay, so this is the plasticity chart. Okay, this is the simple versions of plasticity chart. Okay, the classification of fine-grained soil is achieved by referring to the A line. Okay, you refers to the A line. Okay, to the A line where any point above A line is considered as clay, while below A line is silty soil. So above A line is clay and below A line is silty soil. So the percentage of liquid limit, you need to know the percentage of liquid limit. Okay, that will be the indicator of plasticity behavior. So if the liquid limit is more than 50%, okay, if more than 50%, that would be considered as high plasticity. Why? If it's lower than 50%, then it will be considered as low plasticity. Okay. You can also refer to the complete versions of plasticity chart where details stage of plasticity ranging from very low to extremely high plastic can be defined. So there's a more detailed plasticity charts where it will further categorize. It's maybe this one is very low, maybe there is a intermediate, okay, medium high, or very or whatsoever. Okay, so that's a detailed one, but to me it is actually sufficient to just identify which one is high, which one is low. So the indication is looking at the liquid limit value. Okay, if more than 50%, it means that it can be categorized as high plasticity. If less than 50%, then it would be low plasticity. What is low, what is high? Okay, definitely you have to figure out first what are the types of your fine grained soil. Let's say it is above a line. Okay, it's above a line, so we know that it's clay. So to further describe, okay, that clay, okay, we want to check in terms of its plasticity. Okay, because everything is about plasticity now. When you carry out Atterberg limit test, you have to determine liquid limit and plastic limit value, right? The reasons why, because you want to get the plasticity index value. So everything is about plasticity. So once you already know what is the types of fine grained soil, you want to know whether it's a high plasticity or low plasticity. Let's say it is more than 50% liquid limit, which we know that it is high plasticity, and from the previous analysis, you know that it is clay. So it means that it is clay with high plasticity. So it is a clay and with high plasticity. Okay, so another thing that you need to know is previously when you're talking about coarse, okay, when you're talking about coarse, okay, after you identify whether that coarse is gravel or it is sand, the other things that you need to describe is in terms of what? You're talking about its grading. Okay, you're talking about grading. So it means that when we're talking about grading, it's either well graded or poorly graded. So that is for coarse, but not if you are talking about fine. Okay, if you're talking about fine grained soil, okay, you want to know whether it's clay or silt. So the other things that you want to describe for clay and silt, okay, is its plasticity behavior. Okay, and this plasticity behavior we can only determine based on the determinations of moisture content. So you want to know whether it is high or low plasticity. Okay, so that is actually the other things to describe for coarse and also for fine. So if any times you're talking about coarse, it means that it can be also further described as well-graded gravel or well-graded sand or poorly graded gravel or poorly graded sand. But when talking about fine, you cannot say that it is well-graded clay. No. Okay, well-graded silt. No. You're talking about its plasticity. Okay, nothing to do with the grading for fine grained soil. The other way around also for coarse. Okay, you're not talking about high plasticity gravel. No. Low plasticity sand. No. Okay, plasticity is only for fine. If you're talking about grading, then you're talking about coarse. Alright? Okay, and from the previous video also for a plastic limit, you'll see that how they determine the amounts of water, okay, indicate that is the value of plasticity limit. When they have to roll, okay, to roll the sample, initially they make it the sample into this shape, like a ball shape, and then they divide a little bit, okay, take certain portions and they roll it into thread, okay, thread, and they need to observe the appearance of cracks. They need to observe the appearance of crack. Let's say even though before they roll the, okay, again you have to observe the appearance of crack. Okay, you need to observe the appearance of crack. Okay, if let's say before you roll the sample it's already cracked, so it's already cracked, it means that it is in the stage of what? It is in the stage of solid. Okay, you're talking about plastic, so plastic is the, what it means by plasticity is the ability of the material to be mold. So when it reaches the plastic limit, it means that it start to be mold. Okay, start to be mold. If it's already cracked, it means that it is here. Okay, it's not even reached the plastic limit. So we want to check the cracks happens, okay, at any directions, vertical or horizontal, exactly when this thread, okay, reach 3 mm diameter. So the cracks can only first observe at this size. If let's say beyond 3 mm, you still cannot see the crack, which means that it's already exceed it. It's already exceed the plastic limit. Okay, which means that you put too much water. If before 3 mm is already cracked, means that it's too dry. Okay, you want to see these cracks happen exactly at 3 mm, then it will consider as the plastic limit. Okay, I think that's all for now. Okay, we already discussed on two sets of testing, okay, that you need prior classifications of soil, which is based on particle size analysis and also Atterberg limit test. Okay, for particle size analysis, you have safe analysis and also hydrometer test, and for Atterberg limit test, you need to get the liquid limit and plastic limit value. Okay, so later on part 3, we will discuss on some standards to be used, okay, for proper classification. With that, thank you very much. See you later.